last session. Thanks for everybody for coming out. Hope you've had a good conference. We're going to be talking about database migrations with Gradle and Liquibase. My name is Dan Stine, and I work at Copyright Clearance Center. I'm in our architecture team there, and I lead our platform engineering team that provides build and deployment tools to all the product development teams, and also some common libraries for our Java application developers. I've been using Gradle for 4 years, and one theme that runs through my software development career is inefficiency and inconsistency really annoy me, and I work on weeding those out as much as possible. Copyright Clearance Center makes licensing solutions that help our customers get, share, and manage content. We're a global company with headquarters in Danvers, Massachusetts, north of Boston. And like most companies, we have a wide range of industry-specific software systems, internal, external users, organic growth over many years. Organic is good at the supermarket, but not so good with software systems. But, it's sort of the curse we all have. And 4 years ago, we adopted a product platform strategy for this portfolio and had close to a greenfield restart in some ways. And this talk will talk about part of the delivery platform that underlies that program. So this is our agenda. We'll have some context setting. We'll talk about Liquibase a little bit, and then we'll get into the heart of the talk with talking about how we adopted it for development and deployment process. So just to set the stage, database migrations, we're talking about database structure changes, often called schema changes, also reference data, not transactional data, but lists of various allowed values and so forth, and potentially database logic, even though we really don't have that. Historically, we handled this in a pretty ad hoc approach. We had a bit of a framework that we used on some projects, but it wasn't pulled out independently, and we get copied from project to project and get modified in small or maybe less small ways. It wasn't always used, and so that caused different kinds of trouble. And development teams would share a common development database, and you'd have the usual sort of if somebody checked in code that depends on a new column or something like that, you'd crash and burn until you updated. So intra-team collaboration was difficult. We had the forced synchronous updates was really the only solution to that shared database. And you had to deal with variations if you went to a new project, and if you started a new one, you had to figure out what the strategy was and go from there. At deployment time, we had plenty of trouble too. It was a manual process. Where are the scripts for this app instead of that app? It's different. Which ones have been run in this environment? Which ones haven't? How do I run them? Is there some kind of shell script maybe that helps me run it, or do I have to copy and paste them into a SQL prompt or something like that? So given all those manual difficulties, you end up with all these recurring problems where you have mismatches between the app and the database, and people are trying to figure out what's going on, and it delays testing, and sometimes testing has to restart because you realized something wasn't valid, and so there's plenty of pain, and it was impossible to automate because of all the variation we had in the process. So, and that stood in the way of our dream of self-service deployment, where QA staff could deploy into the test environment sort of directly without the help of the operations team and the DBA team. So the standard software platform that we started, we said homogeneity is one of our key principles. You can have exceptions, but you need a clear, valid justification for it, and otherwise use the usual stuff. You see the kind of tools we would use, including Git, Gradle, Jenkins, Artifactory, and Liquibase. And we adopted not just tools, but the process around them. So a standard development workflow for all the developers, and a standard application shape and operational profile. So as applications go from dev to test down the line into production, you want them to look the same in certain ways so that the people deploying them and managing them over time don't have to learn 12 different ways of doing things. So what was our vision for database script management? We want it integrated cleanly in the developer workflow as you iterate before you even get into the environment pipeline, but then as you get into the deployment pipeline, you want it to go smoothly. Developers should be able to commit their database script, and the process takes over from there, just like with the application code. You commit it, and it goes into a build process and comes out in the WAR file, and it's just clean like that. So that's what we, that was our high-level vision. How do we do this? Well, let's manage the database scripts as first-class citizens, have them right in the same repository along with the application code at a standard location, just like you have source main Java or whatever. A standard execution engine instead of minor variations here and there. We want to have automated tracking of the applied migration, so you know which scripts to run, and you don't have, oh, we already applied that, but I didn't know that kind of problems. And to deal with the intra-team collaboration, we introduced databases at the developer workstation level, so you can have your own private database that doesn't interact with anyone else. And then, when you commit your database and associated application change together, that's, it gets published cleanly like that. So the tools we selected, one was Liquibase, which is sort of describing these database migrations as code. It's a database agnostic. It's relational database tool, but supports many different relational databases, and it has the execution engine we're looking for and that automated migration tracking that we discussed. Then we wanted to use Gradle. We were already using it for other parts of our process, and we want to use Gradle for the usual reasons. We can create custom tasks that help with our development workflow and provide conventions for common operations, and but maintain the flexibility to deal with things as they emerge. That's sort of one of the fundamental powers of Gradle. So Liquibase, this was basically our opportunity to ditch our homegrown framework and use something more broadly adopted and supported. Liquibase provides a vocabulary of what they call database changes or refactorings, and these are sort of those low-level operations like create table, add foreign key, drop column, things like that. Those changes get grouped together into change sets, which are groups of changes that should be all applied or not applied, atomically. And then change sets are grouped into change logs, which are the actual files that are managed in version control. So a change log can have many different change sets.
How would you do
A unit test for
the database, all the change you apply any
okay. We do some static analysis and we do some testing as well, and I'll show you some of that. Yep. I'm sorry. Yeah, the question was about unit testing of the scripts. So we'll talk a little bit about that a little bit later. So some more basics: change sets. Those atomic groups of changes are uniquely identified by an author, an ID, and the file they live in. And Liquibase will track the execution of those change sets by that identifier in a special table it creates in the database. It also has a lock table so that nobody can run Liquibase concurrently with somebody else that's running it, just in case. And then it detects modified change sets by checksumming the operations inside the change set. And that's important because if you're saying, well, this change set has already been applied somewhere, and then somebody modifies it, that's not how it works. You need to add a new change set that does the thing. So maybe you added a column and then you realized later, oh, well, I don't want that. We can't just remove that column from the create table statement. You need to have a new one that actually drops it because Liquibase can't really keep track of what's going on. So it checksums things to at least detect if you've done something you shouldn't have. And the model is pretty much like the rule for Git. If you have a Git commit and you publish it such that the rest of the team can get a hold of it, you can't rewrite history and take it out of there, or else there'll be trouble. Same idea with a change set. If you've applied it somewhere, don't modify it. We talked about how Liquibase supports different database engines. We adopted Liquibase version 2 at the time, and it supported only authoring of change sets in XML. And so we didn't love that idea, and we adopted a groovy DSL on top of Liquibase to author our change sets. Liquibase version 3 supports like YAML and JSON and maybe a couple other formats. We might have gone down that road, but this is where we are. So what does a groovy change set look like? Here's one. In orange is the sort of key pieces. So we have a change set, and we see the ID and author that are part of the identifier of this change set. We used like a date stamp kind of approach for the ID, and then and then it lives in some file. And this change set has 3 changes in it. It creates a table, it adds the primary key, and it adds a foreign key constraint to some other table. And that's your atomic change. You don't want to create the table, but somehow the primary key doesn't get created or something like that. So that's what a change set, simple change set looks like. At our company, there's a bit of a learning curve, probably, like adopting most tools. We talked about the don't edit change sets once they've been applied rule. That was definitely one, we had to learn trial by fire. And, it's best if the team can really understand the underlying model of how the tool works, because then you can understand, well, really why shouldn't I edit a change set? And that works, that's a good general principle. As much as possible, if you can understand how a tool works, then you don't have to sort of memorize magic rules. The rules don't become so magic. And we added some standards on top of that, just our company policy. We said, well, these Liquibase change operations don't require a schema name or a table space, but we want those to be specified. We have particular schemas we want. We don't want to use the default table space, things like that. And we want to parameterize the schema name and table space in the sense of, in Groovy, you can define a property and then reference it, so, which you can't do in XML. And that helps with consistency and potentially future flexibility if you want to move things between schemas. So that's sort of a quick intro to Liquibase. So how did we integrate it into our development process? Well, like we said, we had already been using Gradle, and we're doing workstation builds, we're doing CI and release builds, we have integrated with our IDE, we have local app servers spinning up on the Gradle command line, with like the Tomcat plugin or the Gradle plugin, which is just fantastic. Like the ability to just check out a project and run it from the command line is great, but many projects need a database underneath them, and so this is like, we wanted to fill in that gap with it. You have your local database, but you want to be able to just run the scripts in there and be able to really run the app. So we wanted the integrated database development into our Gradle workflow. Here's a simplified standard project structure, single Git repo with a multi-project Gradle build. This has like a UI and a REST service that it provides and a common service layer that they both use, and a DB project. Usually there's sort of some additional sub-projects for layering purposes and things like that. And it gets published to an artifact group. We're calling it, our example here in the presentation will be my app. So we published it to the group copyright my app. And we published the UI and REST apps as WARs. And then we'd also publish the database artifact to Artifactory as well. And to be able to build this, we created our custom Gradle plugin, CCC Postgres, and that would specify our standard script location, or a source set at source main Liquibase, and we'd use a standard package where it's myapp.db, and standard versions of things like Liquibase and the Postgres JDBC driver that you would use to execute the change sets. We created a plugin extension, and the key part of that was the main changelog, what we called the main changelog, and that's sort of the entry point. Changelogs can include other changelogs, but you don't want to have to say at deploy time, well, run these 9 changelogs or something like that. So have an entry point, top-level main changelog that includes all the others, and so that's what this is. And so then we created lifecycle tasks for the development workflow, also in the Gradle plugin. You want to manage that local database development that's isolated from other developers. You want to pull in the new schema changes, run some task, and be ready to go. We built this on a Gradle Liquibase plugin. So we were using the Groovy DSL to author the change sets, and then we're using a Liquibase plugin to help execute them with some of our conventions layered on top. And in a visual sense, it looks like this. You've got your local workstation, you're bringing your source code down from GitHub, and then there's 5 standard Gradle tasks right there. One that just creates our CCC database inside your vanilla Postgres install. Then you can create the schema that is inside that database, and then you spend most of your time running the update task, which just takes that main change log and runs it, and Liquibase will say, oh, it's pointing to no new change sets, I won't do anything, or there's 3 new ones because I just brought one in, and it'll run just those 3. And so you loop there, and then maybe you get into trouble somehow, or sometimes you just want to start fresh. So we have the drop database task to drop that, and a reset-based changelog task, which I'll talk about a little bit in a couple slides, sort of why we do that. But that's the basic workflow. And so we have sort of full round tripping here. You know, bring it in, start things up, and restart whenever you want. So yeah, the typical developer loop is to run that update task and then either work in their IDE or from the command line. And this really makes it simple for people who are more casually involved with the development of any given project to run it. Sure, the standard thing, it takes a while to set up your development environment every time you start a new project and stuff like that. Well, here you don't have to set up your IDE because we have Tomcat run, and if you just have your standard database thing there, you can run the scripts in and you're like up and running, depending on what you want to do. But if you're just kind of poking around and not really developing, that's probably good. You could debug the Tomcat process or whatever. So if you're in a central role, like on our team in platform engineering or whatever, like this is, pretty much heaven. So talking a little bit more about the lifecycle tasks here, we, the first one that creates the database can't run as, our custom CCC user. It has to run as the default Postgres user, and then, the others run as that CCC user, and drop database goes ahead and, drops the CCC user in the database. Then we get to that reset-based changelog task that we mentioned a little earlier. And so all of these tasks are actually running Liquibase change sets, not just the update one. The create database, create schema, and drop database are running Liquibase, just sort of common scripts. And so if we didn't have this reset-based changelog task, you'd go ahead and run the change set to drop the database, and that's cool. It would go away. And then you'd say run create database, and it'd say, oh, I've already run that change set, so I'm not going to do anything. And then you don't have your database. So reset-based changelog, sort of steps outside of Liquibase and blows away that tracking table so that then you can actually recreate the database. So, that's sort of, one thing we discovered, but it works fine, and, we were up and running. So there's other ways that you could configure what the plugin is giving you. You could upgrade the version of the Postgres driver by setting a property. By default, all the, these tasks, when you run them, run against, localhost and your local Postgres install, but you can override those if you want. And we'll see some reasons you might want to do that later on. So we've got our teams, up and running. They're authoring their database code in these change logs, but Liquibase is new to, many or all of the team, and we have some company standards we're layering on top of that. We're at a build automation conference, so let's automate and, help out in these areas of standardization and compliance. So first thing we did was static analysis. People are probably, a lot of you familiar with CodeNarc, which is the static analysis tool for Groovy. And in addition to providing rules that you can run on vanilla or arbitrary Groovy code, you can author your own rule sets and your own rules to go in them. So we wrote some custom CodeNarc rules that could analyze that Liquibase Groovy DSL and do various things. And then we apply it via the Gradle CodeNarc plugin, and we can fail the build if we find some kind of violation. So we talked about those required attributes. Create table certainly requires a table name. Like, it wouldn't make any sense without it. So that's required by Liquibase. But things like schema name and table space are optional as far as Liquibase is concerned. So we wrote a rule that says, well, actually they're required. So if we see a create table statement without a schema name, we can fail it right there and catch it, before it ever gets released into the wild. And then we can, we only do that for some of the optional ones, and then, so we leave others that are optional as Liquibase. From Liquibase's perspective, we leave them optional. So, but we can categorize every attribute of a change into one of these categories and say these are sort of the full spectrum of attributes that are acceptable here. And so it pretty quickly became clear that this can help in an unintended way, which is catch typos in the code. If you misspell table space, it's going to catch it right there because it says it's not required by Liquibase, it's not required by CCC, and it isn't one of the optional ones I know about. So let's just flag it down, and bam, right away you've caught that somebody had a typo, and instead of finding out a year later that this huge set of data is in like the default table space instead of the one you want, you can catch it right away. Another example is the required parameterization. We said that schema name and table space shouldn't be hard-coded. They should be sort of set by a property, and so this is actually a snippet of the CodeNarc rule that uses the visitor pattern and looks through map entries in that DSL, and any time that the key of a map entry is schema name or table space, make sure that the corresponding value is not a constant expression, and if it is, you can add a violation. And you can look through this code in more detail. The slides are up on the site. So another thing we did was add the ability to run Schema Spy, which is a tool that provides a visual representation of your database structure. If you have a running database instance and you have graph viz installed on your machine, you can just generate that visual representation. So by default, it points at the local database, like we said, but you can provide some properties and point it at your dev or test database and get a picture too. So that was a nice benefit. Getting back to your question a little bit about testing, so let's list sort of what are we doing for continuous integration for database scripts. Well, so we can compile the Groovy in the first place and find if there's any syntax errors at the language level. We can do the CodeNarc analysis, which catches the policy violations like the hard coding or just DSL violations where you have a typo or something that's not supported. And then we do have, we call them integration tests because you're sort of what we do is we spin up a H2 database in memory and run the Liquibase scripts against them, and that'll catch other classes of errors, like if you're trying to index a column that doesn't exist or something like that, it'll fail out right there. And then of course we also used this not just to test the database scripts, but to then test the data access layer in an integration test and that kind of thing too. But yeah, so that's been working pretty well. When we do a release build, we sort of talked about how we publish the Groovy scripts from source main Liquibase into Artifactory, and then we also tuck away into the manifest that main changelog entry point from the configuration DSL that was used, certainly at development time to run things, but we want to tuck it away in the manifest so we can use it at deploy time as well. So, that's what we did there, and so that was sort of that's sort of what we did for development. Then moving on to deployment, we, backing up, we started, this platform, we focused on the build side for a while, then we moved into deployment, and we started deployment by looking at the apps themselves and not the database side, and we came up with a system where Jenkins is sort of the UI level and it can orchestrate Chef runs. How many people familiar with Chef? I assume, some, okay. I don't have time to go into too much detail about that, but there'll be a little bit of a review here. So, Chef is a way of describing the configuration of a system, of a server, and that's what we use to say, a war file should be in this place and should be of this version, and Java should be installed, and Tomcat should be installed, and things like that. And that worked well for us, but the database deployments were manual. It was better than the ad hoc approach we'd had before, but it was still time-consuming and error-prone. So this is the slide that's sort of more information about the automated application side, and it's important because we're sort of going to refer back to it when we talk about how we did the database deployments. So Chef has the concept of an environment file. One purpose of that is as you have your environment pipeline, dev, test, down to prod, you have these Chef cookbooks, which are the things that know how to deploy your app, and they're tied to application versions. And so as your application version moves down the pipeline, you need your cookbook to move down the pipeline. And so in the environment file, you can sort of say which version of the cookbook is currently applicable in any given environment. So that was what we used to sort of control the flow. And then Chef has a concept of data bags, which are just JSON files effectively. And the cookbooks, there's certain things that you want to do in every environment. But then, of course, every app has environment-specific configuration, database credentials and database URLs that are different in every environment and other kinds of things. And so the cookbooks are sort of effectively parameterized by information that comes from the data bag. So when you deploy to a given environment, it says, well, get me the test environment values from the data bag and use that in my Chef run to configure my app. And there's the concept of encrypted data bags for sensitive information like database credentials. And so that's where we'd have the passwords. And we pulled all this together under Jenkins, and Jenkins jobs, it would take an environment and an application version and you'd hit go, and it would do the deployment. So in visual format, it looks like this. So we have our source code flowing into a build process with Gradle and Jenkins, publishing to Artifactory, and then Jenkins and Chef doing the application deployments in an automated fashion, using information like those data bags and environment files from the Chef server. The problem was over here with the manual deploy of the database side. So we have our operations team, our DBAs, basically checking out the Git repos from GitHub, checking out the appropriate tag for the environment, and running that same update task that we had for the developers that's parameterized, so you can, in fact, pass in the DB host and the port and the password and everything else. And so this was better than the arbitrary stuff, but you still had to manually sort of configure all this, and you'd have DBAs with these command strings for every app, for every environment in a notes file, and they're copy pasting them onto the command line and stuff like that. And so, better than before, but still there's plenty of room for error, and it takes more. It takes more effort than it should. So what we really wanted was to combine the database deployments into that automated box orchestrated by Jenkins and get a full stack automated deployment. And we want to maintain that data-driven design. So if you think about maybe a project introduces a new database artifact and it needs to move down the pipeline along with the app, but the production version doesn't have that, is older and doesn't have that database artifact yet. So we use the environment file to sort of list out the database artifacts that apply. And so each time once the version of that app gets to an environment for the first time with that database artifact, you can update the environment file. And that maintains both the data-driven aspect and the controlled flow down the pipeline. And then we wrote a Gradle database deployment task that at a high level grabs that script jar from Artifactory, takes some information that we already have in the Chef data bags. So we just talked about how, we have the database password there, and we have the URL to get to the database because the app needs to be configured with that. Well, let's use that information also to execute the Liquibase scripts at deployment time. We have that information already. So in a little more detail, it looks like this. In Jenkins, we have a job, in this case, myapp.QA, and it takes, maybe we run it with environment test and version 2.1.12. So our Gradle code says, all right, I'm going to reach out to the Chef server for my app in test and grab whatever database artifact names are applicable and grab the database URL and password. Do the usual thing, go to Artifactory, and grab a jar. That's, bread and butter for Gradle, and then invoke Liquibase with the right stuff. These deploy jobs, we introduced the concept of an application group. Maybe it sort of should be called a deploy group, but it's like my app. Well, it's really not one app. It's that UI, and it's that REST service, and then it's a database artifact. So we want to, but they're all versioned and released at the same time with the same version number, so that job should take care of the whole thing with one button press. And we further partitioned them by the deployer sets. So one of the reasons we're using Jenkins is because it can do access control. And so we can say, we have a .dev job that'll let the developers deploy to development, and a .QA that'll handle the test environment and leave an ops job for production, that kind of thing. And yeah, so we created the Gradle task called deployDbArtifact, and it was parameterized with the appropriate information it needed to do to go build up that dependency selector string, copyright myappdb 2.1.12, so that it could reach out to Artifactory and grab that jar file, look inside, get that main change log that's our entry point, get the database URL from the data bag for the test environment, and get the encrypted password from the Chef data bag, and run it. One thing about the database access, so Chef is, you write your Chef cookbooks in Ruby, and there's a lot of code, in the Ruby ecosystem to work with Chef. There are Java bindings from the JClouds project, and so we're in Groovy, we want Java bindings, so we used those, and that worked great for the sort of unencrypted data bags, but JClouds didn't have support for encrypted data bags, so basically it's groovy code. It's in Gradle. We can, glue together any arbitrary logic we need. So we pull in the appropriate dependencies from JClouds and the, Commons Codec library. Make sure you have a JDK that has a Java cryptography extensions, because they're you need that to actually run the code for the decryption, and a little bit of tweaking here and there, and we got that to work, and away we go. So this is sort of like what those deploy jobs at their essence look like. There's a drop down for the environment, so it's certainly not an open-ended entry. It's a drop down. QA can deploy to whichever of the subset of QA environments is appropriate, and ops can deploy to production. And yeah, the operations staff have privileges to deploy to the test environment and so on. Just like they have root access on all the machines. And here's just like example run histories in Jenkins, for the dev job or in the test environment or the production environments. And over time, we end up with data like this. This is real data as we built and rolled out this framework. So in the first part of the graph, so there's 3 colors of lines here for each of the standard roles at our company: dev in blue and ops in green. So in the initial rollout, we're building the framework. We use it with one app, with a couple apps. So that's like rolling it out to a bunch of apps that already exist. So there's a pretty steep ramp up at the start there. Then there's sort of a decline in activity just because it's maybe not as busy time of year maybe. So we see both the blue and the green lines declining. But down at the bottom, we see QA starting to do their self-service deploys, figuring it out. And then once activity picks back up, you see dev jump up there, and QA jumps up right with it, because we've now enabled them to do self-service deploys. But at the same time, ops keeps falling. And that's like, music to our ears or whatever, because we're offloading work from them and we're empowering the QA teams. Yeah?
Do you mind giving us context for that timeline? How long was it?
Yeah, I'm unsure of, I don't think I can. Yeah. And so we see QA rising basically in concert with dev, and that's like you're sort of having your loop at the early stage of your pipeline. Dev, you do build and deploy to dev, and then you want to get into the test environment, so those two track pretty closely. And then at some point you get stable enough that you go to production. And then near the end of this graph, you see right at the end QA actually even overtakes ops in raw number of deploys that are done. And so that was another big milestone where not only have we offloaded work, but enough that QA is actually even doing more deploys than ops was. So, yep. And then I wanted to talk a little bit about extensibility of this framework. So we built it originally for a given app to manage, to deploy and manage the tables that it owns. It stores its data in some set of tables. But we had some other kinds of database deployments that weren't so sort of standard in that sense. But it turned out we could adapt our framework to handle them pretty easily. And so the example I'll share here is, we had a centralized roles and permissions app. You don't want to have to build, that kind of thing, like a UI to assign users to roles. You don't want to build that into every app. You want a centralized one. And so, we built that app, and it had its own database project to manage its schema. But then any consuming app, for example, the My App group, needs to manage the particular roles and permissions it knows about. So if it says, I have an admin role or a supervisor role or whatever, that app is the one that knows what its roles are. And so basically what we want to manage is reference data, but it's not reference data that lives in your app. It's reference data that lives in this roles and permissions app. So in such a scenario, the My App project would have multiple DB projects. Its regular DB project to manage its schema for its persistence, and then the standard -RP -DB project to manage its reference data and its roles and permissions in the centralized app. And we want to deploy both of those with new versions of that app as they move down the pipeline. And so in our framework, it was really essentially a pretty minor addition of conditional logic. Instead of just always deploying to the application's own database, we'll check if the suffix of the artifact is one of these RP DBs, then deploy to the RP database, and otherwise do the thing we've always been doing. And we could do that because we built with flexible tools like Gradle and Groovy. And it's like the kind of change and extension that feels good. Like you're still maintaining the conceptual integrity, and you've got an essential difference, and it's modeled sort of nicely in this conditional logic, and then you just go from there. So that was a happy thing. We did that. This is one example. There were a couple other examples as well. So to wrap up, just a few observations. We really relied on the power of convention and consistency here. Everybody following the same rules. Once we had the first, we built the framework and we had the first few apps deploying their schemas in automated fashion. The dominoes toppled quickly, and the apps 3 through 15 or whatever came on board very quickly. And that's another one of those satisfying moments. And we've talked about it a couple times, the power of flexible tools and building blocks, because unexpected things come along, and every enterprise and organization has legacy complexities and special cases. Sometimes you do acquisitions, there's strategy changes, whatever. And if you have flexible tools, you can react to that instead of saying, uh-oh, we're like down a hole and there's nowhere we can go. And the new database project types were one example of that. So you want to know your tools. We talked about this with Liquibase. Certainly people need to need to know how to do something. And ideally, if they understand the underlying model, that'll help them know what to do even better because they know why they're doing it. And we found another effect we found was that schema changes are no longer restrained by process. If you think back to an era where things were manual and error prone, you might say, well, I'd really like to refactor my database a bit, but it's just going to be a pain to get it down the pipeline and get it organized everywhere. But if we have a process that lets you do that, you can refactor your database. And so, there's the mantra in automation circles: if it hurts, do it more often, and you'll be better off. Well, so then once you do that, if it's easy, you can do it more often and end up with reduced technical debt because it's easier to pay down. And database development and deployment processes aren't exactly exciting for most people. You can talk about distributed systems or single-page web apps or new programming languages, and that gets people pretty fired up. But sometimes you got to just dig into the dirty work to realize the overall value and the overall vision you're trying to get to. And in a case like this, managing relational database scripts, for all the talk about alternate data stores and things like that, relational databases are still the bedrock. They're not going away, and it's a really strong investment you can make. So dirty work can be exciting, because efficient processes are exciting, and reliable and extensible automation is exciting. And of course, we have to put in, the obligatory mention of continuous delivery, as we all try to, move further down the spectrum of, easier releases, more frequent releases, things like that. People, teams, companies, industries are all sort of, moving in that direction over time. So, at the end of the day, we ended up with our full stack automated self-service deployments. We saw how it reduced the workload of our operations team. It safely empowered the individual product development teams for QA leads to do self-service deployments into the test environment, which notionally they own to begin with. It's their test environment. It should be configured the way they want it. They can, they don't have to file a ticket for someone else to do a deploy. They can just do it. It significantly reduced our dev to test time delay. And then we recovered, we recovered bandwidth, and we can reinvest that in various things. We partly invested it in more reliable and more frequent software releases. That's the sort of continuous delivery part. And then other high-value initiatives that need people to dig into them and work on them for a while, but they didn't have time because they were busy untangling manual deployments gone awry or something like that. So, that's really what I have. Here's a few resources. The third bullet point, that's a talk I gave last year with a lot more detail about our Jenkins and Chef deployment process for the application layer. And so you can check that out if that sounds interesting. And I'd just like to thank our engineering team back at home and the organizers of the Gradle Summit. And thank you all for coming. We've got 5 minutes if anyone has any questions. Sure.
Have you evaluated Flyway
Yeah, I'm aware of Flyway. We did not evaluate it. We knew about Liquibase and, you know, tried that out and it looked good to us and, you know, we've had success. So, but yeah, as for an A/B comparison, I don't have really any data. Yep. Sure.
When you deploy and the initial data, how you handle it? The initial data on the database is going to be scratch installation, or is based on some image you already have some custom
Yeah.
data?
So the question is about initial data, and so I don't know, are you talking about like for testing purposes? Yeah, so yeah, I mean I had some slides about integration testing that I cut out because I just had too much to fit into the time slot, but you know, we also built up some help for, in addition to, at integration tests, running the schema description into like H2, we built up ways of, you can create, you know, instead of source main Liquibase, you can have source integration test Liquibase, and it'll have other change logs that can throw data into the database that your integration tests might expect. So does that kind of make sense? Yeah, so I mean, I didn't have time to go into detail about that, but yeah, that's a problem we encountered and came up with a solution for.
They have their own database.
Well, and so that was just for integration testing. As for the actual deployed environments, I mean, we didn't really, as part of this effort, we didn't do anything there. If that, yeah.
Data migration.
I mean, you can, if it's part of your schema migration, I mean, if you're like splitting a column into two or whatever, well, that's sort of part of your schema migration. And so in your change set, you can, you know, I don't know, create the two new columns and, you know, run some kind of SQL that puts the data there and drops the column and stuff like that. So yeah, I mean, that would fall under this. But, you know, the sort of transactional data for, you know, just your inventory of X or Y or Z, I mean, that's not covered by this process. So, yeah. Do you have a question?
Yeah, so it seems like when you're deploying into production, you're still running Liquibase.
Yep.
Do you have any like pushback from DBAs that you're not aware of that?
Yeah, so the question's about, you know, we ran Liquibase all the way down the environment pipeline, including production, and, you know, was there any concern on the part of DBAs or something like that? And, you know, I mean, not that I'm aware of. I mean, they were just really glad to be out of the business of sort of like, you know, doing these manual database deployments. I mean, we had sort of already crossed the bar of, you know, getting database passwords into Chef encrypted data bags, you know, so that wasn't really a concern. You know, I think, you know, developers could, you know, write a bad change set that does something harmful, but if you use the exact same process and the exact same change sets sort of all the way down the pipeline, you know, because it's all automated and, you know, version controlled and things like that, you know, you've got a pretty good chance of catching it before you get to production. I mean, I guess that's what I could say about that.
Another question, if I can. Have you ever had to do rollbacks?
Just a couple times, and that required some additional work. I mean, there's other stuff we didn't talk about. There's concept in Liquibase of tagging. So every time we do a deployment of a version, we'll sort of tag in the change log. And so then you can sort of say roll back to tag and, you know. So we've done that a little bit. I wouldn't say it's, you know, ultra smooth right now because we've only done it a couple times. And, you know, we got through it. But, you know, since we haven't done it often, it's not easy at the moment. But yeah. Yeah, anyone else or, yeah. Or here, let's let that guy, yeah.
So my question was also on your experience with Liquibase and the rollback mechanism.
Oh, okay.
The one project that I worked on where we had Liquibase,
Okay.
the rollback mechanism was always, you know, the right stepchild that I paid attention to. So if you actually got to the point where you needed a rollback, it wasn't trustworthy, right? Did you guys have kind of the same experience?
Yeah, I mean, you know.
Do you have confidence that the rollback mechanism, as you guys implemented, is working?
Yeah, I mean, we, you know, the vast majority of the time, we're just moving forward. And so, yeah, we're not rolling back often at all.
So solution rather roll back and roll forward.
Yeah, exactly. You know, we're a shark. You always swim forward or whatever, right? But,
Did you build it into your Chef scripts to be able to do rollback
Well, so yeah, the chef that does the application layer, yeah, that you can definitely do. You know, it's sort of like you're declaring, I want version something or other installed on this server, and I can change, you know, that version forward or backward, and you know, there's no state there. It's sort of just, you know, a war file just obliterates the prior war file, so it's not that difficult. It's really like Jenkins is at the top, and it does Chef and Liquibase. So when it runs Liquibase, it uses data from the Chef side. So I mean, it's not, you know, quite that simple, but you know, because we wanted, you know, why duplicate the data? We've already got it in the Chef data bags. Well, so yeah, so it works fine on the Chef side for the applications, and then yeah, on the database side, it is trickier. We haven't had to do it in production. We did it a couple of times in a test environment. We had to find our way a little bit, but you know, it worked well enough. But you know, again, we haven't done it that often, so I wouldn't say it's well oiled. I'd have to go back and figure out exactly whether it's fully automated or not. I don't, because we've only done it a couple times in a couple years. So, okay, so I think we're out of time, but I can take more questions after, so thanks a lot.